the last of our series of affiliate seminars for 2023. Now, the Fenner School has around 110 affiliates who make a tremendous contribution to the work of the school in terms of research, in terms of community engagement, in terms of teaching, and with our research scholars. And so we're just celebrating the work that they do and including at our dinner that's coming up on Thursday evening with the affiliates. My name's Jamie Pittock. I'm the convener of affiliates at the Fenner School. This afternoon we've got the most fantastic couple of presentations looking at regenerative agriculture, which is quite a focus for many of us in the Fenner School. And so we're going to start with Dr. Luke Peel from the Mulloon Institute, looking at regenerative landscapes, and move on to the one and only Dr. David Freudenberger, looking at biodiversity sequestration in sustainable agriculture. Gentlemen, thank you for presenting today. They will each present for 15 or 20 minutes, and then I'm going to have to hand over to Dr. Matt Koloff on the affiliates committee to MC the questions. Thank you. Luke, thanks very much.
Thank you, Jamie. Lovely introduction, but I should probably note that I'm definitely haven't got my doctorate as yet. One of those things that we're working on. First of all, I'd like to acknowledge our First Nations people where we meet today, and in particular where we work. We're in a bit of a combined area of where there's about 3 or 4 tribal zones, including the Yuin, Ngunnawal, Gundadjara, and Ngarijo. So first up, I'm going to talk to you about the Mulloon Rehydration Project, a catchment scale project. But first of all, it started off as a pilot project on the Mulloon Creek Natural Farms, funded by Mr. and Mrs. Tony Coote. Just to give you an idea, for those of you not familiar with what we've been doing, this is what some of the Mulloon Creek looked like in the 70s, and through our rehydration works, what it looks like these days. And so the Home Farm project was a pilot project instigated in 2006. It was quite new in terms of the concept, and so we had to work with the local catchment management authority of the day. And even with not being able to fully implement what we wanted to do, we were still able to, within 5 years, increase the carrying capacity on our floodplains, the most productive part, by about 60%. It was about 63%. Dramatic improvement in the volume and quality of that water. So we were really having a positive effect quite quickly on how the water quality was affected. And we believe that we were having greater resilience during the drought. So remembering this is great millennial drought, the middle of the millennial drought when this was instigated. And we've had since a significant improvement in biodiversity, our green surface area and vegetation response. And we believe also that we've moderated our microclimate effect locally in this valley floodplain pocket. So to give you an idea, 2005, this is what the creek looked like at one of our more famous spots that we did on this 3-kilometre stretch of creek at Peters Pond. And you can see that there was a big gravel bar pushing up. There's also an ephemeral creek that's helping to dump that gravel bar deposit there. And we've reshaped that, and we've ended up that we've got a great response with now the aquatic plants that have generated there, and also the ponding effect that we were able to recreate even during that drought period. And another view of that at the ground level gives you an idea of that classic, very sharp bank as it's been eroding out, and as that gravel bar built up, any pulses that came through continued to push on that outer bank. So we've done those modifications, and as you can see, the response has been very good, particularly with that fringe and aquatic vegetation, which acts as a buffering zone as well as a habitat. Other examples along this 3-kilometre stretch, you can see in many cases what we would commonly referred to as leaky weirs, but more technically they are biogeoengineering structures, and the fact that the biology takes over eventually to the point where in this case it effectively hides it, which is what we want. We don't want it to be a classic built environment. This is working with nature largely. Now, we had a lot of the landholders downstream were up in arms about this, feeling that that greedy Mr. Coop was going to be stealing all their water. And yet they realised, particularly the downstream users, realised that the water coming through was not stopped and the water quality was better. And so that really added the premise of a landholders group getting together along with other people such as Peter Hazel, who was a big driver of this as the environmental officer for the area, to then expand this to a 23,000 hectare catchment project. And that was going to include 50 kilometres of creek. There's 20 plus landholders involved. And even the landholders have been able to be involved in the monitoring, and there's various components of that that we'll talk about. We've also conducted training and education, and we've developed now a whole program around that that we now roll out nationally. There's also the landholders were even more actively getting involved, and this is about how you bring that community along with you, and that they're now also sharing knowledge between themselves, even conducting their own farm walk and talks. And we've also involved First Nation people in a number of variety of projects. We've then expanded that project, as I talked about, in the first stages was in 2018, in the most recent extreme drought that we had from 2017 to the beginning of 2020. And you can see in that first picture there on the left that it was a very dry creek bed. The structure was put in, and even by early 2020, we could start seeing the response of even the first few little showers that would start that ponding system. Another good example on another property further down, that one of the big responses that we get very almost immediately is that aquatic vegetation response. And already we could see the response was quite phenomenal on this property in particular, where the Phragmites and Combungi really took off. We did actually transplant some starter plants, but the rest of this has done it itself. The thanks of people like Max and Penny, who have done a lot of this transplanting. 2019, well, the drought was really severe by now. As you can see, the creek is dry. This was often how Mulloon Creek was previously. It was very flashy. There'd be lots of water, it would rush through, and then it would quickly dissipate. And through a dry period, an extended dry period, it would almost amount to a dry creek bed. And yet by 2020, this system was starting to regenerate. We then, after the drought probably really broke in August, when we had a 1 in 50 year flood event. And so what Peter Hazel and the crew are trying to do here is recreating the floodplain interaction with the creek and get those fluvial hydrological patterns happening. And you can see those hydrological patterns happening on the left-hand side, just after the peak of the flood, where you can still see those fluvial pathways that are ephemeral, that get activated when there's a flood event. And this helps with the whole recharging of the groundwater system. But it's also about the fact that what we've done with these leaky weirs is slowed the water down, we've de-energized it, and we've actually encouraged more localized flooding, such as what these floodplains were designed to do. Our ecological and geomorphological systems have been, in Australia, have had a long time of perfecting this. And it didn't take too long before that water had dissipated in August to the point where it was back to the main channel. And so what have we been doing in terms of a large array of monitoring? Well, particularly it's been heavily assisted by the TMI Science Advisory Committee, with a number of people here today who are in that committee, such as David Feuerberger and many others. And with that, we've also generated a peer-reviewed paper that was published at the beginning of this year that highlighted and outlined the monitoring program for a long-term purpose. So we're measuring hydrological in terms of surface and groundwater. That includes soil moisture these days as well. climate stations, which are more than just a weather station. We're also measuring incoming and outgoing solar radiation. We're trying to measure energy and where it dissipates and transfers or transforms into soil temperature, or whether it's into plant growth, and the biotic pumps and that microclimate effect that I mentioned earlier. And of course, in doing so, we're also monitoring the soils in terms of their physical, chemical, and biological status. And all of this data is being managed by our partner Hydroterra, based in Melbourne. We're also measuring a wider range of flora and fauna. That's fish, frogs, birds, macroinvertebrates. Dr. Paul Cooper from ANU is doing those ones. We do rapid appraisal and riparian condition, landscape function analysis based on David Tongway's method, and also the ephemeral drainage line assessment. We do biomass sampling, photo points, drone imagery. There's a whole range of things. And we also partnered with SIBO Labs that are doing an amazing job with their satellite monitoring products. So that is also a product that our landholders get to access with a 5-day time step of their biomass and what their food on offer is. So trying to help understand what the landholders, what's important to them, but also collecting scientific data at that really amazing scale to try and collate the information about what is cause and effect and what are those drivers being affected. And so hydrologically, we can say that downstream users were not adversely affected. In fact, they had many positive effects in terms of water quality and quantity. And that total volume was maintained. And we've got very good results for our temperature, salt levels, pH, turbidity, and dissolved oxygen. These are all very important from aquatic flora and fauna point of view, but particularly also the fact that we're at the top of the Sydney water catchment. And in doing so, that's 5% contribution of Sydney's water. So that's important from an end user point of view as well. And so we're reconnecting those waterways with the floodplains, as I said before, and that's a very important hydrological process that our landscape, whether we're talking about the Murray-Darling floodplains or the floodplains in this, the highlands of the east of the Divide. And what we also noticed is that we're building a greater flood resilience. And if you think about this, that all those mini catchments all the way down through to the Shoalhaven, if rather than allowing these flood surges such as we've experienced, all impacting very quickly at one endpoint, usually a town or a bridge or some other major infrastructure, then what we're really trying to say is let's dissipate that energy down through the steps of systems, such as we've got here at Mulloon Creek. It is part of the stepped system of how these waterways move through the landscape and how we can dissipate that energy at each of those steps. And then we actually will mitigate the extremities and the severity of those floods. And what we've noticed with our recent RARC surveys, and we've just finished doing another one, we'll have the results come out early next year, but we've started to get these trends now. In particular, one of the highlights was that we've seen out of all of these transects, and particularly the 20+ transects on Mulloon Creek that I've focused on here, is that habitat is definitely picking up, cover is picking up, even though you can see there that some of those sites haven't improved. And what I might say is that 1/3 of these transects still have not had rehydration works. So this is a work in progress. Our natives have really started to pick up. That's helped by our transplanting and planting of thousands of natives, but it's also that there's been its own regeneration has been occurring. And we've also been able to affect debris and features in a slightly less significant way, but there have been improvements, and particularly when we've had these extreme events of extreme dry period that I was measuring through and the extreme flood events. Frogs, well, there've been a really good response to the frogs and the monitoring that the Mulloon Institute's been doing in conjunction with ACT Frog Watch initially, and then also with Sam Patmore. And what are some of the key results are that we've been continually seeing an improvement in the frog number of species and the average number of species per transect. And that's just along the creek. What was also of interest was that we started monitoring the wetlands and dam sites, and that's had a very similar and positive response. I think anecdotally, I can say that the initial results or feedback that we're getting was that due to the fact that we've had so many flood pulses or mini flood pulses this season, and the wetlands are really recharged, we actually noticed that many of the frogs had moved out of the creek where they'd been sort of pummeled a bit and had spread out into the wetlands. So we're hoping that we'll capture that, but either way, we're very positive that the frog species are showing a positive effect. Fish surveys are being done by University of Canberra, and I'm expecting the formal report to be coming through, but the initial results are very positive. Now, I'll highlight two things. The initial baseline project showed that which was our pilot project, which are sites 1 and 2, that there were none of the mosquito fish sighted there. Now, we know that observations were that they were there present, but scientifically we didn't have that evidence. But what we've noted is that now that we've done these leaky weirs further down in sites 3, 4, 5, and 6, that the mosquito fish have all but disappeared. They've also disappeared from our comparison ones as well, in Bombay, Reedy Creek, and Jarrah Combined Creek. And so we'll be very interested when we do another fish survey next year with UC to find out how is that trend going. Birds the bird surveys have been done by Damon Oliver from New South Wales OEH. Unfortunately, COVID has got in the way recently, so we haven't had any more results since then, but we're pretty keen to get back out there. But the initial results were that, that we know that they can be quite seasonal and migratory. But what we've really noticed is that we've got 7 of the rare and declining species and 4 threatened species in the area that have been noted. And what the takeaway message was that we were picking up a trend in 2018 in the middle of that extreme drought, was that a number of those species were still present. And interestingly, the rare red-capped robin, which normally are west of the Great Dividing Range, were turning up in our catchment, and partly because we had food, water, and habitat available. We also had platypus and water rats were a sideline observations. I'd like to thank actually Angus for knocking this last graph together after we were doing some SIBO Labs satellite analysis. And some key points there that I pointed out there is that you can see when the pilot project was started, this is an assessment on ground cover in the pilot project property. And what we note there was that we can see a trend, even though we were still going through the drought, that when the drought broke in 2010, you can see ground cover pick up. And then it's continually trending upwards. And the other orange and purple colors either side is showing you that median range and compared to other properties in the nearby vicinity. So it's a good cross-check as to how you're comparing with similar climatic conditions. And you can see that the trend is that we're continually improving. And what is of particular note is that during that extreme drought, in a comparative and relative way, we were going upwards while everyone was going backwards. And that set us up well for not only when the floods did occur that we had ground cover, but that ground cover was ready to take on board the change in the climatic conditions, and the response was faster. We believe that we've actually helped reignite the resilience in this floodplain to be more productive through those extreme periods and protect when those other perturbations such as a flood come through. And it's not all about the creek as well, even though that's a lot of the focus, but this is an amazing system that we've also been doing what we call leaky contours up on the ridge lines. And so landscape rehydration is not just also about the floodplain and creek connectivity, but it starts from the ridge line all the way down, because locally you've got surface water that's then got the potential to carry your resources. And as a farmer, that's your resources. Your water's not only disappearing and you're quickly back into a dry land situation if you can't soak that water in. So these contours slow that water down, increase and encourage to infiltrate that water higher up, and the groundwater will move much more slowly through the system. Meanwhile, what it's also doing, because we spread it laterally, we're actually encouraging that whole hill slope to be rehydrated. Now that picture on the right that you can see, in this case, we did not transplant any wetland species here. These have self-propagated on their own. Now, whether that seed bank was already still there, and we were clever enough to identify that this was a natural step in the landscape that potentially had these little perched wetlands, or whether animals brought them, is a bit of a moot point, because the response is that we've actually created the conditions that nature has jumped in and added to. This looks along the side of this contour, and what we've done is planted something like that. I think we're up to about 4,000 plants along this ridgeline, Angus. I can't remember exactly, but you can see that even during the extreme drought, by having those contours that just helped capture any water that we got during that extreme drought to hydrate that system, it saw those plants through, and not only have they just existed, but they've actually prospered very well. And we've just continued right along that whole ridgeline. So what are some of the take-home messages are that landscape rehydration is fundamental to the environmental and our farm outcomes either way. And there is room for having a combination of both. This integrated land management approach is what we do in many other places across Australia, but particularly even here. We highlight that it is about the better management of soils, plants, and water in an integrated way, relative to your climate and respective of your land use of the landowner. And there's a way of how you can actually mix both of those up and get benefits, co-benefits. So what is in particular importance is that Australia being the most, the driest inhabited continent in the world, it is all about primarily, one of the underpinning things is managing our water better. There is enough water, we just need to be better and smarter about how we can work with nature to maximize the water that we get. And then with that, using the plants and the soil in that integrated way to either have farm outcomes or environmental outcomes. And if we address that small water cycle, we can reconnect the carbon and nitrogen cycles. And I'm hoping that that's a very good link to David's talk that comes in afterwards. Because waterways are also that essential corridor of how we link through the catchment. So that's our way of how we bring the community along. They're all linked by these water pathways. They're also a major conduit, if in particular that these are regenerated and rehabilitated in this way, that they're a conduit for flora and fauna to travel and move through the system and be connected again. And water is life, but as we've noted also recently, that it can be highly destructive, both for farms, the environment, and for infrastructure. And if you're interested in many of these projects related to any of the monitoring we're doing, I've got a large list there, very extensive list that can be broken down to chunks of honours, masters or PhD projects, and working with a postgrad funding proposal. And I'd just like to highlight that we've really now expanded our work right across Australia. In fact, this map is already out of date. I can highlight that in Central Australia, we've gone from having done a workshop that we're now doing an on-ground program of works there to do rehydration, but major works up in the Great Barrier Reef catchment, which has made some significant improvements, and especially in sediment removal, and some fantastic work in Western Australia in the sheep and wheat belt, but particularly all down the southeast coast with northern New South Wales right through to southern Victoria. And we're hoping to instigate some more projects in other states as well, but there's so much work to be done. I'm sure everyone understands the importance and value. Thank you, everyone.
Luke, thank you very much for that. That's fascinating, especially that last issue about the National Rehydration Initiative. It makes me wonder, as I've been wondering for some time, is if we start to think at regional scale about rehydrating landscapes as part of adaptation to climate change, to what extent will we need things like the Maroon Basin Plan as farmers start to move towards less reliance on irrigation water and thinking about mixed production systems in those landscapes? What you're doing is absolutely vital. So without more ado, any questions from within the room for Luke? Clint, first of all.
Has there been any study done on the animal side of things, the small mammals, and is that being seen to increase at all?
I'd like to, it has been on the list of things to do in terms of when I talk about the Science Advisory Committee, there's quite an extensive list, but unfortunately we haven't had the funding to go that far, besides some anecdotal observations on water rats and platypus in the area. But no, nothing officially yet.
Luke, can you tell us how the sensor data network is being used? Have been able to quantify the exact kind of response to the treatments, and is there more weirs to go in different places?
Yes, so we haven't quite finished installing leaky weirs in just the last bottom section, mainly because we were just getting some of those leaky weirs in just days before that 2020 flood, and we haven't been able to really get any heavy machinery. We've got materials on site ready to go, and similarly for a very large chunk of one of the largest property, which is right at the very upper part of the catchment. So there's all plans to do that. In terms of the using more of the satellite imagery, there is certainly plans. I've already got highlighted to my colleague Susie Miguel's that's what we'll be looking to do. And what we'll aim to do is using that satellite imagery to cross-reference with, say, the RARC surveys to look at vegetation response in that riparian condition area, not just at the sites, but its connectivity right along that whole pathway. And similarly, but in a different way, looking at more extensive analysis on the ground cover and production systems. Yes.
About the piezometer data or soil moisture data?
Yeah, so I've just finished billeting a Norwegian student, a student from the Netherlands, and he's just finished writing his paper. That will go up very soon. But what we've seen is that there seems to be some connectivity with the floodplain piezometers with the stream, but there's also quite a lot of through flow that's coming in off the hills. So that talks about also that effect of groundwater being infiltrated at the ridgeline and how it also flows through the system. So it's a very complex groundwater system. And then the other part would be is then to have someone also conduct some very intense studies using the soil moisture data as well, because that's also that very upper soil profile where your production systems are. So there's quite a lot of analysis. We've been collecting the data, and we hope that it's a honeypot for some very keen and enthusiastic students.
Richard.
Yeah, thank you, Luke. Richard Beggs here, Sustainable Farms Collection Net here.
Yes.
Last year, if you may remember. I wonder if you mind if I change the topic a little bit away from the environmental impacts of agriculture and just ask you a question about the Mulloon's attitude to impacts on the animals themselves in farming. Does the Mulloon have a policy on customary practices that involve surgery that anesthesia, like for example, castration, tail dropping, mulesing, and so on?
I know that fundamentally that Tony Coop was all about having the farming system that supported the natives, but also that there was enough resources for all. And the other part was that even with managing feral animals, likewise, a bit of a lighter touch, but still a necessary touch to still manage them. And then in terms of animal husbandry and animal welfare, we do our utmost, because actually our chicken farm that operates there and pays my wages, it is all about biodynamic and working with nature. So we try to minimize any chemical inputs. So in the way that we graze with our cattle, the idea of doing high intensity short-term grazing with a good recovery period also means that from a health point of view, that we're not having to deal with worming issues and using the chemicals along those sides of things. So there's a greater reliance on chemical usage from our perspective, but we don't dictate that to any of our landholders. They still have their choice on how they manage their livestock and their land, but we do encourage them to try and transition to what not only is less chemical usage, but one might say from a farm profitability point of view, less purchasing of those inputs, those external inputs that can be quite cost heavy in fertilizers and pesticides and herbicides.
Thanks, Luke, for the talk. Early on, you made a point about the possible impact on downstream uses of the water, and I think you emphasised quite, a lot in the talk about if you don't have an impact on a landscape scale, you know, if you're just benefiting the one farm, then ultimately that, I guess, isn't something that you're going to be able to roll out broadly. And it just got me thinking about the whole idea of the leaky weir or a contour line. From an engineering point of view, it has to leak just the right amount, right? Because if you get that wrong and you actually are just making dams, then you're recreating something that has been problematic. So I guess my question is, how do you know how to get that level of engineering right, and that you subsequently got it right?
Yes.
Especially given, you know, variability between years and rainfall and all these things, they're going to make it pretty hard to detect.
I quite agree, Saul, and this is why our consulting arm takes very much a high level of pride in the fact that there is a level of technical skills required to understand how to read the landscape broadly, and then what that means in terms of identifying those steps. If we're just talking about leaky weirs and creeks, of where those external inputs are coming from, either as ephemeral waterways or other pathways of water and groundwater, but also reading the landscape and understanding where strategically to put a leaky weir, and then understanding where in context of what resources you've got there available, whether there's a remnant old tree that you can anchor into some of those other site specifics. But we do a lot of modeling with looking at the average return interval of flood intervals, and we understand also what the parameters are of the potential volume of flow. And so we go through a very painstaking series of processes to model and map that, and then instigate a plan that then has to go in for a controlled activity approval. And so often enough, so these leaky weirs are not designed usually to go to top a bank. So the whole idea is that they are not intrinsically a dam, but they are designed to just slow that water down. They are porous to a large degree, even though, you know, there's a range of large rocks and logs. That's the structure basis, but it's filled in also with smaller rocks and gravel and sand, and then plants to try and do. So it is porous fundamentally, but with the idea of leaking slowly, but recreating those steps and making sure that we've got this chain of ponds system in the driest of times. So trying to account for that driest time and the wettest time, and that we have the capacity that we can slow it down enough and spill when those high volumes do come through. Yeah.
Yeah, thanks for the talk. It's Helena from, I'm working with Sustainable Farms here at Penner as well. My question is about practice change, and you know, I'm just wondering about how you're leveraging you know, the way in which you're documenting and linking outcomes to sort of management interventions. You know, we know from the adoption, you know, thousands of studies on adoption of agricultural interventions that childability and complexity are two really critical factors that determine the likelihood of adoption, and information that farmers get from trialling and practice on their own place is actually the most important information to guide their decisions around adoption. So, I mean, I guess in looking at it, you know, it seems very complex. I wonder about the trialability and how, you know, if a farmer was interested, where would you say that start in terms of trialing something like this on their place?
Yeah, so we've thanks for that question. And in many cases, we're actually we've been running a model that we would call of how we roll that out. So some examples would be is that we get an inquiry from a landholder, and it sort of relates also a bit to what Saul was saying before. You can get an effect locally for that landholder immediately, and there's some roll-on effects downstream. But where we do note that we think where you really get a much bigger significant benefit is when you do it at the community level. So then to bring the community along, we use a mix of that we run workshops from an information point of view. We've got this, let's call it a landholder that is interested in rolling this out. We then use that as a demonstration site locally. And then we would then probably follow that up with either the local land services or catchment management group to partner with us, so that there's a continually bringing the community along. There's an introduction, there's a follow-up, and then there's well, if there is the interest, how can we all band together, including the local land service or catchment management group or the council, to say, let's try and now scale this up and access some funding to be able to do so. And so there's a lot of projects out there with the future drought funding projects that we've been partnering with, of where that is one of those big factors of where we feel that we've made some real impact at that community scale and engaging the community and be able to expand it. Because you're very right, many landholders have come to our field days and they go, oh, would this really work at my place? Well, I understand landholders, you know, like most people, you can take in information in verbal, written, or touch and feel. And many landholders like to touch and feel, like to see something in person. And that's why being able to demonstrate in their own local area is highly valuable, and finding that champion in the landscape is a you know, of real value to us. But we've also got to engage all those other broader stakeholders, such as your local council and CMAs.
All right, we might move to the last question.
We've got
Really
one.
move on. What?
We've got a question
We've
online.
got a question online. Okay. So we need to be fairly quick on this, otherwise David won't get a chance.
Sorry, David.
I'll make it quick. This is super interesting. I presume it has to be rolled out at scale if we want to manage Australian effective with climate change, but I suspect funding by, you know, the powers that be would look at this and say that looks really hard and really expensive. So but I would guess the economic benefits are actually way over the cost if you actually measure them. Have you done much economic modeling on what ecosystem services values?
Yeah. There have been inroads into doing ecosystems modelling, but there's also been, I think you've already touched on it, what would be the cost of not doing this in terms of mitigating for future flood?
It seems like cumulatively that must be a massive value. Even
Yes.
People downstream.
So we're working for accounting for nature in some of those aspects, and other groups, but there's collating that information and that evidence does take a bit of time. But at the same token, there's already some early evidence that does suggest, and then it goes back to your first comment of that it may appear as being costly. Well, one of our biggest costs is the regulatory hurdle, and we do need the regulatory there to make sure that it's done properly. But the cost impediment and the time and effort of what it can also invoke, and that's what we're finding, is that we crash into such things as that it goes into, say, Crown land tenure, and that invokes a development approval, and that invokes a biodiversity assessment, a heritage assessment, a First Nations assessment. And you can get drowned in paperwork and bureaucracy for the next 2 years. And yet, when we've had the approvals go through, we can finish a property in under a month. And the cost of the materials, because we normally would preferably access our materials locally to try and not have to, you know, the cost and bringing anything new into the system, so to speak, working with what's locally. So the cost outside of the regulatory is very, very positive, and the return on investment is very good. It's the cost of the regulatory, but we acknowledge that we do need to have some checks and balances still.
Okay, last question online.
Do you have any general advice about the type of catchment conditions that would not benefit from kiwis or contouring?
Look, generally speaking, there are not many landscapes here. So if there are some, it'd be ones where you have to use a level of wariness. And this would be in areas where there's sodic soils and acid sulfate soils. Now, we're doing some very good work in Western Australia, which have got sodic soils and salinity issues. And we're having some, you know, major wins over there. And the fundamentals on that would be is that if we can increase the amount of fresh water held in that soil profile, fresh water will naturally help hold down that salinity that's been rising. So that's one way of conceptually looking at that. But that's not to say that there are some landscapes that would be of a red flag that we would have to make sure that we took into account any of those site-specific challenges.
Luke, thank you so much for that talk and for really educating and informing those of us who were maybe less aware of the work that Mulloon is doing, and also the potential for linkages between Mulloon and fauna.
Yes.
Great talk.
Absolutely.
Thank you very much indeed.
I think one of those people is Justin Moore that's here. We've got some very good connections with as well.
Now, I'm very pleased to introduce our second speaker, Dr. David Freudenberger. David and I think we first started working together on a project prosaically titled Better Knowledge, Better Bush. We could have.
That goes back a long way, 20 years. Yeah.
Along with Sue McIntyre and Sue Briggs, and we've been colleagues ever since. So over to you, David, to talk about biodiverse carbon farming.
Yeah, so this will be mostly a photo essay with a limited amount of time. I'll start with the premise that native vegetation is an important component of regenerative agricultural systems. And as we know, many agricultural landscapes are down in the last few percentages of native vegetation, native woodlands, like here on the western slopes of New South Wales. The 30% threshold is a separate seminar, but that's sort of the level of native vegetation cover that is an indicator of sustainable regenerative systems. And of course, with so many landscapes below 30%, revegetation is required. Natural regeneration doesn't work very well because of the loss of resilience. Who pays for the expensive revegetation process, starting from a clapped out wheat paddock? So it's sort of the emerging market that I've been engaging with since 2008 is biocarbon sequestration. I had 5 years with Greening Australia, starting in 2008, where the carbon market and Kevin Rudd were trying to come together, but that didn't quite work. And so one option for funding the revegetation process is trees on farm, funded by the carbon polluters. So I've been monitoring re-veg in various places the last 20 years. The take-home messages is restoring plant diversity is really hard, which means it's expensive, but getting some key structural elements back into landscapes like trees and shrubs is doable. And the good news is they're quite resilient, as I'll show you. So one of my case studies is Southwest WA, the Gondwana Link project, which has been thinking big and bold for the last 20 years, reconnecting a biodiverse hotspot across southwestern WA. It was a grassroots, and it remains a grassroots community and business vision. The case study I'm looking at is the Greening Australia penny up property between Bush Heritage Australia purchasing the remnant vegetation. Greening Australia took on the task of revegetating the entire clapped out wheat belt to reconnect the Stirling Ranges to the southwest and the Fitzgerald River. And there's a lot of carbon biodiversity activity in this part of the southwest, and this map is quite out of date. Back in 2007, 2008, my colleague from Greening Australia, Justin Johnson, mapped out the broad soil types which drive the broad various vegetation types. So rather than a mixed soup smear of seed across the landscape, tried to dial in the seed mix by those various colors, and those black lines are making, this is a carbon project, very early large-scale carbon project. The black lines, contours are where hand planting to ensure eucalypt survival, to enhance eucalypt survival took place. At the Google Earth scale, it's pretty bold. It's the whole farm that was cleared in the 1960s. Greening Australia purchased it from the original farmer who cleared it. And that's why I said, well, that was a waste of 30 years. And that's what it looks like. The southern portion of the property was revegetated in 2008. Then over the last 10 years, the northern section of the property is now completely revegetated. And those darker areas are plantations of native sandalwood planted to native hosts. Some novel technology. It used to be direct seeders were just a single on at a time towed by a ute, but this is now farming scale, so you need farm tractors, and this is a 1960s wheat seeder that was modified to sow direct seeding. Those bands are where the hand planting went in, and in between the band is the stipple of native vegetation that was visible from satellites in 2013. That's what it looked like in 2015, thanks to Chris Brack's drone and an honor student that worked with us. And that's what it looks like in just a few months ago from the satellite image complements of Google Earth. That's the sandalwood plantation up to the north, which will be harvestable in fairly soon. And then 43 plots, 6 rows by about 10 to 20 meters have been monitored with the help of various students of mine. I was able to fly over and get the work done on an annual basis for 10 years. After 5 years, we published a paper that showed the good news is we were able to restore about 7 to 13 plant species in each vegetation group. The bad news is more than half didn't show up. There was an enormous amount of seed and that was just never established. And unfortunately, that's typical of direct seeding. There are certain species you can get in pretty effectively with direct seeding, and there's a whole lot you can't. And this is just the woody component. We're not talking about the ground layer, herb layer, which I'll get into next. And then some of that diversity disappears really fast. And so again, this is at year 5. By 2019, all the acacias they're short-lived, and they're now sitting there as seed. That's not regenerating because acacias tend to need heat and smoke, and fire has not gone through this landscape yet, but I'll talk about fire shortly. This is an upland Eucalyptus occidentalis vegetation, or soil and vegetation type going into Mali. Again, the short-lived acacias are gone, and a few dominant species of eucalypt in the long tail of bits and pieces that show up in the plots. One of the challenges that some of them have been aware of is accounting for carbon is either modeling or field-based, but it is highly variable. It's not a wheat crop that's fertilized and managed to be uniform. It's really, really patchy. And the models are averaging. And so there's potential to be either overestimating or underestimating the actual amount of carbon unless you have high resolution methodologies for accounting for carbon. Some of the other bad, challenging news is there's been a complete loss of ground cover. And this really surprised us. Started out with a semi-native grassy recolonization post 30 years of wheat crop. So April 2010 is looking pretty functional, a lot out there. 2011 is growing really nice, thank you. And then you start seeing the ground cover being lost because of the massive competition for water in these sorts of systems by these shallow-rooted eucalypts and acacias. 2013, she's bearing out. 2014, 2015, 2016, but we're starting to see at least the leaf litter accumulating, the branches, the acacias dying out. These are potential sites for regeneration of ground cover. They're providing function in terms of nutrient incorporation, increased water infiltration when you have this litter layer being established. But that's what our acacia remnant looks like. I mean, a Yate acacia remnant. It's phenomenal. This is dry season, middle of autumn, but over winter, the diversity can be up to 150 species per 10 square meters. So the ground cover in its remnant condition is mega diverse, but certainly not in re-veg. And so, yes, thanks to carbon, we've gone from a degraded, dysfunctional, and biological simple state to, at least by 2019, a lot more structure. Thousands of cubic meters of additional habitat if you do the volume calculations. Lots of vegetation carved. Functionality, yeah, but there's no regeneration, no natural recruitment, and a lot of bare ground. And it's not terribly diverse, though the birds are coming back. Some small mammals are coming back, being monitored by Bush Heritage Australia. Case number 2, what happens when you burn it? This is the only second data set of what happens when a wildfire goes to young re-veg. This is revegetation that was planted in 2008, including FENA students who used to take out to the Bush Heritage site near Breadbow, and it all burnt in February 2020. So what happens? Well, I've been monitoring this 2013 planting with 30 transects, over 500 plants still remaining across those transects. And it's located north of Breadbow. You can see those little stripes, which were some experimental direct seeding over there, but it's the Bush Heritage purchase that's flogged out African lovegrass encroached property, and those colored lines are the transects, permanent transects, and they're known plants that I track through time. All my monitoring is tracking individual plants through time. Before the fire and after the fire, and now earlier this year, what fire? Quite remarkable recovery. Looking at the column on the right, percent survival, 80%, 90% around the eucalypts, the acacias, some of them completely dropped out, others have hung in there. But overall, 52%, but the eucalypts 82%. Some eucalypts are bomb-proof with 90% survival. And this is after the 2017 to 2019 drought. Everything is regenerating for the eucalypts from lignotubers and epicomic growth. Some of the eucalypts were completely burnt to the ground. They come back from young lignotubers. These are only plants that are 7 years old. The acacia dilbata is regenerates from root plates. So we've gone from one plant to over 50 stems. So we've gone from individual acacias to now clumps, thickets of acacia, very different structure. And even some of the acacia melanoxylon, I thought they were dead. I monitored them the year before. They're scored as dead. There was nothing there, and they've come back up occasionally. Acacia rubida has not regenerated at all, and a little bit of seed. These plants were old enough to put down seed, but even though the fire went through, I haven't seen much seed regeneration from seed. A lot of bare ground, and it burned out an enormous cover, very thick cover, African lovegrass, Eragrostis curvula, which is an invasive perennial, and it's opened it up to native ground cover regeneration. So that's pretty spectacular. Bring on the fire. These results are consistent with what we published back after the Canberra 2003 fire, Green Australia and CSRO, where I was at the time. Had monitoring data before and after the fire, and the only eucalypt that was lost was an obligate reseeder, and the seed wasn't, the trees weren't old enough to reseed, but anything that had a lignotuber or epicormic growth shot up, the acacias shot up, landscape cover recovered very quickly. So there wasn't any difference in landscape functionality after 5 years. So in summary, restoring native vegetation, agricultural landscapes, you can, through carbon, through Landcare funding, government funding, philanthropic funding, whatever, you can get some basic structure, some trees and shrubs back in. Getting the ground floor is possible, it's expensive. One of my Green Australia colleagues, Paul Gibson-Roy, has done some beautiful work on restoring the grassy ground cover, but it comes in about $40,000 to $50,000 a hectare, which is payable by development offsets if you're working in the Sydney Basin, where development offsets for grassy woodlands are worth tens of thousands of dollars per hectare. The good news is, resilient systems, even at a young age. So biodiversity carbon farming is an essential, necessary part of agricultural regenerative landscapes, but insufficient to do the full ecological restoration story. So thanks for that. Quick run through. Justin, you got your hand up fast.
I was going to interrupt you, but I waited till the end. Thank you. In the Gondwana link where you got great vegetation cover, but no grass cover. What about some, not fire maybe, but just thinning? Maybe you just pull out some of the shrubs early and let some light to the ground and reduce that water competition. Plant initially to get establishment and then manually thin later.
That's the challenge. And that experiment needs to be done. It hasn't been done yet. The downside is you get immediate loss of carbon. So depending on yeah, and so you can biochar, whatever, but it's part of the maturity, long-term maturity of our understanding how carbon biosequestration can be part of the restoration process. And so whether it's a mechanical disturbance, biochar, mallee oils to help thin it out as an economic driver, or it will burn at some point. Because if there's no ground cover to burn, but if a fire gets going into the canopy and it's a low canopy, it'll go boom. And I expect then you'll get a big pulse of the acacias coming back and thinning, that kind of stuff. Another question.
Yeah, given that Southwest WA has dried out about 20% over the last 40 or 50 years, how much would climate change impact on your work there, especially with lack of ground cover?
So the challenge, there's a published paper that looks at the climatic and biological filters of getting establishment by year 2. So there is an enormous loss of seedlings through the first summer. The good news of climate change in Southwest WA, summer rainfall is increasing. So, a critical 10 millimeters might be actually enough to get through that bottleneck of the first summer drought. But once they're established, man, these things are tough. Lignotubers, lateral root systems. I've been recording individuals, shrubs that have gotten stuck under a eucalypt, and they've been sitting there at 10 centimeters of height under a eucalypt for the last 10 years. You get them established and they're tough. But, and that's the good news, climate, these systems are pretty resistant and can deal with a large degree of climate variability. Saul, you have your hand up.
I do. So I'm also thinking about the problem of loss of the ground layer. Surely even easier than thinning is just don't think about it as a patch scale issue and have areas that you don't plant. Presumably, if you took that picture from further back, there would actually be parts of the landscape that still have that ground cover, and maybe. In general, we ought to be cautious about thinking that we should be applying any one method to a whole landscape, right?
Yeah, absolutely. Terrific insight. The good news is there's enough farm tracks in boggy areas that you do have that operational patchiness. And what Justin Johnson has done with Bush Heritage on a Bush Heritage property is they'll have the broad scale direct seeding, and then they'll put a lot of effort into biodiversity nodes, where you're getting back some rare Banksias, and you might have a teaspoon of seed from a rare plant species, and you really baby those along. And so the challenge with biodiverse carbon farming, there's the attitude, it's a plantation. And you hear about carbon plantations. You put in fast-growing eucalypts and single species, and that's happened in this district. But if it's carbon plus diversity, then there's opportunities to get much smarter. Yeah, you need to get your big bang for your buck by getting some fast-growing species, but then even 50 square meters here and there to get that patchiness and restore the diversity at patch scales rather than saying we can do it everywhere.
I've got a question that relates to this, David. In terms of what you'd expect to see if landscape function type continue, where you had no ground cover, you're starting to get accumulation of organic matter and debris, which says to me, the next step on from that starts to look like soil carbon incorporation, better water holding capacity, and then the next step is you start to get recovery of your.
That's right. We don't understand the hysteresis
Yeah.
of this system going from a wheat paddock. And so I'm hoping to be able to see our 15-year, we've done 10 years, 2 more years from now, we'll do year 15. I've been doing LFA, haven't published it yet, but I've been doing LFA across the 42 plots.
Which says to me, if you were going to do a thinning trial, you need to have your control of no thinning and looking at that.
Yeah, because the system may eventually look after itself,
Exactly.
thin out,
Yeah.
and getting that carbon on the ground. Conscious of time, but if people need a chip off, but I know there's a few more questions.
And then we've got one online as well.
Okay, good.
Kirsty Yates from RSB. Really interesting stuff. Thanks for presenting. An area with, I guess we do a fair bit of work with farming soils. And given the history of some of these sites, some pretty damaging practices around the soil biota, has there been any work in those revegetation restoration activities to look at what's happening in the soil microbiome and whether or not there's opportunity to contribute to some development?
And the sobering answer is no. The only published paper I know about the importance of soil biotas, our colleague across the road at CSIRO that had developed to commercialization a superior inoculation for acacias. Peat thrall, thank you very much. And unfortunately, with the very variable demand for seed revegetation, government cycles of funding, that product's no longer available commercially. But he did show through nice experimental design that if you get a superior line of rhizobiobacteria onto your acacias, they grow faster, and most importantly, better initial survival, because that's the bottleneck, is initial survival.
There was a recent paper just in the last 2 or 3 months, I think, from University of Sydney about, I think they used just inocular of soil itself from local patches into revegetation.
Excellent.
So they didn't do any genomics type work, unfortunately, but
it's a terrific, and there's been a little bit of work in mine site rehab, particularly in WA, where you're going from mine spoil and trying to create soil out of spoil. There's been some work there.
I would add that Saul Cunningham and I have done work on soil invertebrates in relation to revegetation and looked at how long it takes before you start to see landscape scale effects like changes in water infiltration. So if you plant re-veg on a ridge line, you will create habitat for a whole load of burrowing invertebrates, which then drive water infiltration into the system through the creation of micropores, because they're drilling holes in the soil to lay their eggs in nests. And that might be bees, ants, wasps, termites, ants, you name it. So you can see that sort of effect within about a 5-year period. In terms of turnover of soil, moving from a clapped out sheep paddock with very, very low soil invertebrate biodiversity and a lot of weedy fungi that are causing problems like tangle and other root diseases. 3 years of incorporation of organic matter will turn that system around.
Yeah, thanks for that reminder that the macro component in the soil biota. But
yeah, we had another question.
Hi, Anita Pearson, Institute for Woodridges. I've been involved in tree planting activities in different communities, different parts of Australia, but also riparian revegetation down Moorthorns Creek, which is a tributary of River near Geelong, goes through several suburbs. And that the approach that has been taken there is very much around native and indigenous grasses are included in the whole suite of different species around shrubs and trees. And we've noted huge biodiversity as a consequence of that and the early establishment of those grasses and enabling ground cover back to soils, points and others, because of the time period it takes for those shrubs, in particular the trees, to establish themselves. But the other point is referred to the just mentioned thinning of species. So I've seen examples of tree planting where native trees, eucalyptus and acacias and others will grow quite a tall height, but they're only planted 1 metre away from each other, which, why would you do that? But when you have grasses planted around the same time or within a 6-month period of the shrubs and trees, there's a much better outcome and a higher survival rate. And it also improves the soil, the water moisture, biodiversity.
I mean, the challenge is scaling that up. And so this property was 12,000 hectares, getting in enough native ground cover seed for 1,200 hectares is not impossible. In the US, there's a mature native seed industry where warehouses and processing plants are the size of a Bunnings shop front. Here in Australia, Greening Australia's seed bank fits in a closet. There's those. It's what I call the agronomy of restoration. I've got an honor student from Greening Australia right now that's looking at. There's no published papers on pre-emergent and post-emergent herbicides that are selective enough to keep the natives alive. That's research that has gone on in the agronomic part of the world, years and years ago. So, and then, there's a little bit of unpublished research on using precision agriculture to get the seeds spaced out better, those sorts of things.
I think there's a question on.
Last question.
Yeah.
That's good. Let's make that the last one.
There are actually 2 online,
Okay,
but we'll go through quick.
I'll combine them together.
Okay, yeah. So the first one, any signs that reduced ground cover might result in increased sediment inputs into streams and water bodies. Does the eventual increase in leaf litter mitigate this?
Yeah, so that was back to the point that Matt was making, that getting that organic layer is critical in getting the macro soil biota happening and improving infiltration rates. The general rainfall in WA is this winter soaking misty stuff coming off the Southern Ocean. So you don't get the really strong rainfall events over winter, but again, we're getting more summer rainfall. And so, yes, there are some erosive events happening, and certainly along the various farm tracks at this particular property, the erosion is an issue.
And the other last question was, thanks, David. Amazing results showing resilience of young stands to fire. Carbon farming appears to have some benefits, but nowhere near enough for ecosystem restoration. To rapidly upscale restoration, how do you think we could best harness this long-term funding to create best bang for buck?
It goes back to how did Australia and the rest of the world increase farm productivity, and it was through long-term R&D. I mean, governments have a long-term record and fantastic success at supporting agriculture through its R&D budgets. That has been virtually zero for the 20+ years I've been involved with native revegetation. A little bit of, like, for example, the research we published on resilience to fire was funded by, I was able to get a post-fire grant out of CSIRO. That was about $10,000 to help pay for some diesel fuel for Greening Australia staff and some citizen scientists to go around and monitor. It won't improve without the long-term commitment through CRCs and ag departments and such. So I think about to leave it at that.
Yeah.
The challenge is there.
All right. I just want you to thank Luke and David for 2 great talks. It does my heart good to hear talks about the environment that actually are hopeful and positive. And both of those have been. Thank you both very much indeed.